Okay, so we've got our weight, we've got our normal force, right? And now we've got our applied force. Now, kind of majority do it down into the fourth quadrant. So let's go ahead and draw F applied here. Now I'm starting to label it, okay? Because once you got them drawn, you do want to go ahead and label them. So if you have time, do that, but draw them first. Okay, so now it looks like this. Okay? So your free body diagram, in this case, would look something like this. Okay? I'm not going to draw the normal force yet. I'm going to, first of all, we got these two, and there is a normal force, right? So I'm going to cross this one out, and I'm going to cross this one out, okay? And I'm going to replace each of these by its components, right? I'm not going to label the components. I think you can label them. So I'm going to have this, and this, and I'm going to have this and this. Okay, so now how big should I draw the normal force?
It should be about the same length as the two other forces tip to tip.
Exactly. I add the lengths of these two. So if I add this to this, I get something about this long. So my normal force is going to be now up here. And also now if I've got a frictional force, I can add that in. But it's actually maybe a little better to add it in after we know the normal force and the coefficient of friction, assuming we know that. Like if the coefficient is 0.2, how long is the frictional force going to be?
0.2 times the normal.
1/5 as long as this. Cut this in half, cut that in half, that's 1/4, make it a little small, it's going to be about this long. And it'll be either this way or this way, depending on whether you have motion up or down. If it's a static situation, what's the direction of the frictional force?
Up the ramp.
Yeah, because well, no, not necessarily. Okay?
Oh, yeah, depending on the
Depends on the relative lengths of these two. In this case, I intentionally drew this one pretty big, okay? In this case, the gravitational force and the applied force are such that the thing is going to tend to accelerate up the incline, right? So this applied force is big enough that it overcomes the downward component of the mg force on this ramp, right? Or the component of mg that is acting down the ramp, okay? This is going to act up the ramp, and it's going to be bigger than what acts down the ramp, at least according to my picture here. You don't have details, we don't have numbers in these. I want you to know how to do the picture. I think you can work out the details, but you don't have the picture straight, okay? So, that's what we have, okay? And then, if it's a static situation, friction's going to be acting down, but it won't necessarily be as long as the components, it won't necessarily be 1/5 the length of your normal force. Because the frictional force is not going to be any bigger than the sum of these two. And you have to know that. We talked about it, and you certainly should understand that, because everybody in here's had statics anyway. Okay? Which is why I'm a little confused why we're not seeing as many free body diagrams, which is why we're doing this right now. Okay?